Whether you attended one of our past professional live webinar events demonstrating routing capabilities you need to accelerate PCB design and reliability, or watched the recording on demand, a lot of questions were asked. Let's get the answers. Hi there, I'm John McMillan, and welcome to this special podcast series of PCB Tech Talks, the After the Webinar series. In this podcast, we'll be recapping the questions from both the European and North American sessions, as well as the questions that didn't get answered during the live sessions. So let's get the answers. And as always, be sure to subscribe to this podcast. Let us know the topics you'd like to discuss right here on PCB Tech Talk. When we think of PCB design capabilities like interactive routing, differential pair tuning, constraint areas, and blind or buried vias, many engineers and designers tend to envision that these capabilities are available and perform the same in all design tools. The fact is, the depth of how these capabilities perform can be vastly different, be limited, or even unusable from some tools when it comes time to address the challenges of modern PCB designs, especially as designs become more high-tech and complex. I encourage you all to watch the on-demand webinar, and I'll include the link in the podcast show notes. Today, I'm joined by the webinar demo presenter, Brent Klingford. Hi, Brent, and welcome back to PCB Tech Talk.
Hi there, John. What a great webinar. We had a lot of questions and good ones at that. Let's go ahead and get started. So I'll take one here. Can you define fan-out setups by component? You can only define a fan-out setup globally, but you can use rule areas to help control the spacing between the via and objects within that area, along with what via types can be used within that component or component group area that you create. Another advantage with Pads Pro, though, is you can place vias in cells. You can place traces and vias in a cell or a footprint, alleviating the process of fan out to begin with. So this will help save time in the long run as well. That's a little tip, by the way.
Here's a question. What do these via technologies actually gain you? What's a really good question? So, advantages of using blind and buried vias is that they can help you achieve routing success in dense designs. That is, high net count, small board envelope designs specifically, since through-hole vias create obstacles for routing the PCB. Blind vias remove a lot, and buried vias remove most boundaries to routing. But the average is 25% savings in design time. But don't forget, there's also additional savings for manufacturing a PCB with fewer layers and smaller board size. So you have to take that into consideration. Another thing to think about with regard to blind vias, especially when working on a high-speed design. So imagine a 12-layer board with through-hole vias. If a high-speed net is only routed from layer 1 to 3, for example, the via barrel from layers 4 to 12 essentially becomes a dangling via stub and acts like an open stub resonator. If high-speed performance and design density is an issue, those stubs can be avoided with blind vias. That said, if PCB density is not a big issue, then you consider back drilling to remove those via stubs. Great question.
That was a great question. Yeah, I agree. You can save time using blind and buried vias because it makes design that much easier to route. I'll take one here. So if I have to change layers from 1 to say 5, how does the tool handle what via gets used? The way Pads Professional works in that is it looks at your design rules, and like we showed in the demonstration, you can set up design rules for a particular class of nets, and you can define what vias you're allowed to use within that class of nets. So if we only want to use the blind and buried vias, we just turn off the through vias that are currently in the design, and then when you change layers, the tool will only use those provided blind and buried vias. So let's say if I go from layers 1 to 5, instead of putting in the through via, it will choose the blind and burieds that get you from 1 to 5. So with 1 and 2, and a 2 and 9 in the case of this design, it would choose the 1 and 2 and 2 and 9 and stack them on top of each other and allow me to go to layer 5. So yes, that's handled automatically by the application. Here's another one. What about tuning using time instead of length? So Pads Professional makes it very easy in the Constraint editor system to choose whether or not you use length-based rules or timing-based rules. So you can set that up, again, based on a net or a class of nets using what are called constraint classes. I didn't go over that specifically in the demo, but the capability is there by Constraint class to say, okay, this set of nets is going to use timing for my length matching, but yet I can use length-based rules for everything else in the design. So it's super simple to set that up.
How do you know when the tuned routes are correct? That's a really good question. Advanced routing capabilities like Sketch and Multitrace use the designer's managed constraints input to accurately route and tune the traces. So it eliminates the need to route and manually tune traces, and all the results can be reviewed in the Constraint Manager. That said, manually routing and tune traces is actually simplified as well. So for example, you can select the differential pair tune box. An indicator bar appears in the cursor. You saw it during the webinar, and you can see it in on demand when Brent was routing that remaining DDR trace. So as you modify the serpentine, it will turn green when the lengths are within the correct min-max range.
That was a great answer on the tuning of routes as well, John. So the two questions kind of went hand in hand. I like that. I didn't mention that the target length dialog box is very useful for reviewing your design rules. Let's go with this one here. How many nets can you sketch route at one time? So Paths Professional doesn't prevent you from sketch routing any number of nets. I could sketch route the entire board if I wanted to, but it's not practical because that's not the idea or the intentions of how this feature is used. It's meant to really route nets between two given components. So I really shouldn't be using it to sketch route nets from, say, 5 different parts into one part, or one part into 5 different parts. I want to break it up into groups. Because I'm supposed to be routing it as if I routed this by hand. That's the idea of the sketch router. So if I have a large design with 2 big BGAs that have 400 nets going between the 2 parts, I could grab all those at once and sketch route. The other thing about the sketch routing technology is it's single layer based. In other words, I get to control where the vias end up going. So if in that example of two big BGAs and I'm routing 400 different nets, I would set one layer, it would route what it can on that layer. I would set another layer, it would route what it can on that layer. But if I want to add layer transitions, I define where those layer transitions are, and I get different patterns and stuff of those via patterns. Now, that didn't get shown in the demonstration, but a very good answer because it's a very powerful feature and restriction actually within the sketch routing technology, because the idea is, again, we want to be able to use automation to route like we did as if we routed by hand. That's the idea. This isn't a auto router. It is an auto router, but it's we don't want it to act specifically like an auto router. All right. I'll take the next one here. Does the sketch router add lots of vias? No, in fact, like I just mentioned in my previous question, the sketch router does not add vias at all. You control where the vias get placed when you're sketch routing. Let's see, here's another one. Can we tune track lengths during auto routing? No, you cannot. The Paths router tool lets you do all your tuning after the fact. So you would sketch route the nets, and then there's 2 methods of tuning that we can use. We can use manual tuning, where I go in and I click on a net and I add serpentines interactively, and I can do it at any different segments within that net. Or like I showed in the demonstration, I use the auto-tuning, multi-trace auto-tuning feature. So I selected a group of nets and I just did right-click tune, and the auto router came up and tuned them after I routed them.
Okay, I'll take another one. Do you have to configure the setup for things like routing and teardrops and fanouts for every design? So for every design, setting up and managing its unique constraints is necessary, but with regard to database options and settings, for settings like the stack up and the teardrops, it is common practice for designers to save database templates. For example, you may have a template for a 6, 8, or 12 layer design and so on. A lot of companies' products reuse the same form factor, in fact, or board envelope as a starting point, like for different blades for a server, for example. Saving and reusing design templates can save you even more time.
Let's see, another one here, how to import constraints from hyperlinks into Paths Pro. So with Paths Professional, I've covered this in a different webinar actually. You can use constraint templates to store like your length matching, your topology definitions, areas like that, and then you can use those templates between designs. You can export out a template. You can take actually that template back into hyperlinks, do the simulation on it, and then bring it back into Constraint Editor system. So the template functionality is what you would use to move constraints between particular designs. Otherwise, I think John mentioned this in one of his answers, you can use just overall PCB design template to store your default constraints, class setups, everything. So templates are a very powerful way of sharing common setups between designs. Let's see, let's take this one here. Does blind and buried vias affect reliability compared to conventional vias? With technology today, I don't think the reliability of blind and buried vias is as much of a concern. In fact, I know of customers in the space industry, especially, that have started using blind and buried vias due to proven that blind and buried vias are just as good as complete through vias as well. This one's here. This is a really good question. I wish I kind of would have shown this in the demonstration. How can you tune with curved traces? So it's just a setup that you can turn on within Pro that allows you to route with curved traces. So while it's tuning, it will automatically curve all the corners instead of using the 45 chamfers that we showed in the case of my demonstration.
Here's another question. Why would I choose a blind via over a laser via? That's a good question. To connect signals beyond two layers, for example, from layer 1 to 3, since most designs have plane on layer 2, would require stacked microvias. So depending on the situation, you'd likely use a blind via. But you'd have to look at all of the costs and conditions. Microvias and via and pad are mostly required for small pitch, high pin count components like BGAs, where there's literally no room for a via breakout. Good question.
We ran out of time. I was going to answer this one real quick during the live, but here's the answer anyway. You showed 3D layout and mentioned 3D button, but missed where the button was. To open up a 3D window, you just go to the Windows menu and you choose Add 3D Window. And this will add a tab down in the workspace, and then you can flip between the 2D tab workspace and the 3D workspace. Here's a question that doesn't fully relate to Pads Professional, but I can understand why you might ask this question if you're a current Pads user. What is the difference between Pads Netlist Flow and Pads Professional routing? Routing facilitates not available in the Netlist Flow. So the Pads standard application is obviously completely different than Pads Professional, because Professional is built on Expedition technology. So the two are different tools. So the Netlist Flow process doesn't actually exist in the Pads Professional area. You have to use Pads Designer and the layout tool, and everything's an integrated type flow. So the technology that I did show here in the demonstration is obviously different than what you would be using in Pads Layout or Pads Router to do auto routing. And there it's strict auto routing. You can still use stuff by groups like I did here in Pads Professional. Like I can select a class in the router tool and I can say route, but I don't guide where the traces go. The router just comes up and does its thing. Let's see here. Another one is how to manage the impedance matching with regard to PCB manufacturing. Do we have easy steps to follow? So I showed this a little bit, I guess, in the demonstration, and I've shown it in other webinars as well. Within Pads Professional, whether you're in the layout tool itself or in Constraint Editor system, you have a stack-up editor where you can calculate all of your trace widths, spacing between layers, and it will come back with all the impedance information for those given traces or differential pairs, based on the board material you're using, the distances between the layers, whether or not you have a ground plane underneath it. Is all done via the Constraint Editor system. So you can plan out your entire stack up. We can even output some quick documentation that we can send to our fabricator to approve what we've come up with, and then we can go back and make adjustments. And the stack up editor also takes into account all the manufacturing tolerances like trace tapering. As you know, when you etch a trace, it's not a perfect rectangular cross-section. It ends up being a trapezoid. You can even take into consideration the surface roughness of copper, which if you're doing really high-speed design, starts to become a factor. And the reason we have this great technology in Paths Professional is we're taking it from our industry standard hyperlinks simulation tool for signal integrity. That's why we have all this technology available within Paths Professional. I think we have one more left here, John. Let me see. I'll take this one. I have a question on top layer. Can you manage 60 ohms but not be able to maintain on the internal layers? I think what the question there is, if I'm routing a 60 ohm trace on the top layer, the impedance isn't necessarily going to be the same on the internal layers. So again, Paths Professional by default gives you the ability to set trace widths by layer. I showed that in the demonstration where we can view each one of the layers that are part of that stack up, and then it even gives us the impedance calculations from right within CES. In fact, I could set the impedance in the Constraint editor system and have it provide the trace width for me without even going into the stack up editor. And this Constraint editor system uses the information as far as all the geometry of that stack up editor when it calculates that trace area. So it's very easy to set to make sure that your traces from the top layer are being maintained at 60 ohms when you move to internal layers. And then obviously the layout tool will handle that seamlessly when you move from layer to layer. And again, we showed area rules in the demonstration as well that can help you control that even further. So take all of that to your advantage. It's all in the basic part of the tool. There's no extra options or anything that are required to make all of this function.
Well, I think that's it. Thanks, Brent.
All right. Thanks a lot, John. What a great webinar, and I hope to see everyone back at our next one.
And thank you for joining me for this special After the Webinar series podcast. For more information on this podcast, as well as a link to the on-demand replay of the webinar discussed, be sure to check out the show notes. There you'll also find additional information related to this podcast along with my email address, so feel free to send me your comments and questions. Thanks for listening, and be sure to subscribe to this podcast on iTunes, Spotify, or your favorite podcast app. And be sure to catch the next episode of PCB Tech Talk.